will see that how we can use Google Colab for doing voice conversion. Before, you may have used this model inference part where we will do a voice conversion. You will train your own model or you will download your model. So after that, you will come and do the voice conversion over here. But when you are doing the voice conversion, you may face some difficulties. One of the main difficulty is that you cannot use creep algorithm or RMBP algorithm. It is because they both use GPU. If you don't have a GPU power laptop, then you cannot use these two algorithm. But these are the two algorithm which will give a better output. Okay, if you are using harvest algorithm, it will give you a good output, but the problem is that it is extremely slow, which means it will take a lot of time for voice conversion. So this is the one difficulty that you may face. The other difficulty is that even if you have a GPU power laptop and if you are using a best model like creep model or RMBP model, still the converted voice will not sound that much accurate. Still it will have some kind of noise, or the voice will not sound very accurate. You may train the model for with a very good data set, and you may even train with for many number of epochs. Still the converted voice will not sound that much accurate. It is because it contains very few parameters. You can just change only four parameters for the voice conversion. So this is another problem. It contains a very limited number of parameters for adjusting to get the output. So that is why there is an alternative, that is that RVC voice conversion using Google Colab. Okay, why I recommend to use Google Colab file for voice conversion is that the first thing is they will provide a free GPU so that you can use this kind of algorithm, creep algorithm or RMVP algorithm, which will produce a better output. And also, since we are using a GPU powered, so the output, the voice conversion will take much lesser time when you are compared to RVC GUI. The second thing is here when you come to see for the voice conversion, you can see there are a lot of parameter to tune. You can change all these parameters to produce the output. But when you just see here there are only few parameters to adjust. But when you see the Google Colab thing, you can see there are a lot of parameters to adjust, so you can produce a better output when you are compared to RVC GUI. So this is why I want to introduce this method to you, so that you can produce a better output with the model that you have already created. So now let's get into this video to see that how we can use this Google Colab file to convert the voice using our pre-trained model. I will give the link in the description of this Google Colab file, so that you can store and you can modify the code according to your needs. The first thing that what we have to do as usual, that we need to connect to GPI. So click connect GPU. Okay, so now it's getting connected. Okay, now it's connected to our Google Colab GPU. Then we need to clone our repository. So for that, just click clone repository. Okay, so the repository is got cloned. Okay, the next thing that we have to do is install requirements. Actually, we need to install the packages that are required for converting the RVC voice model. So for that, we just need to run this button. So when you run, we are installing the packages. So it will take some time. Actually, it will take around 3 or 4 minutes according to your network speed, because it need to download a lot of packages. So let's wait for it to complete. Then we'll move on to the next step. Okay, so now it's done. Like you may see this kind of error message. Actually, when I just go up, yeah, actually you can see that everything got installed. But after the building the wheel, that you may see some error message. But ignore this. Even though some packages are not installed and some errors are there, but still the code will work. So ignore this and go on to the next step. So once all this installation is over, then we need to download some vocal saturation model. So for that, just click this code and just run this code. It will just take 30 or 1 minutes to run, and it will just download some models. Oh, okay. So now this part is done. Okay, as of now, just ignore this piece of code and we will come over here. Actually, here it says pre-trained model. Actually, we need to import our pre-trained model. We have our two files, right? We have our model.pth file and we have index file. Okay, let me show my file. So, okay, models. Okay, let's go for Neil Tyson model. See, I have two files. One is model.pth file and another one is model.index file. So we need to upload this both into a folder over here, and we need to give the directory here. But there is a problem in this. Okay, if I upload the two files over here, actually these two files are around 50 MB and 60 MB files, or 100 MB files. So the uploading in Google Colab will take longer time. Actually, uploading in Google Colab compared to other things, like if you are going to upload in Google Drive or Gmail or something else, and compare it with Google Colab, actually Google Colab is slower in uploading speed. If you are uploading something, it will take longer time. So if you are just uploading your model file and index file, and after that if your runtime got disconnected, then all these uploading things will get wasted. Then again you have to upload, each and every time you have to upload. Maybe I used the model today, and like I uploaded the file and I use it today, then I close my laptop and I'm just coming tomorrow and I want to use the same model, then again I need to upload. So each and every time you need to waste around 10 or 15 minutes. Actually it will take longer time. So what we can do is, we can connect this Google Colab into our drive, and we can upload this two model and index file in our drive, and we can use that drive link over here. So if we do like that, then it will be more easier. And also if you upload in drive, it will be always there until you delete, so you can use whenever you want. So this piece of code, what it is going to do is, it is going to connect it to my Google Drive. So I'm just clicking this one. So now it will ask for authentication, it will ask for permission to connect to the Google Drive. So I'm just giving the same Gmail account that I'm using, this Google Colab, and click allow. Okay, so now it's connecting to my Google Drive. Okay, I got notification in my mobile also that it got connected to the Google Drive. Okay, now it says mounted. So if I just go here and try to refresh, then I can see a drive over here. Inside drive, it will show my drive, and inside my drive, I can see all the files and folders in my Google Drive. Okay, I'm just going to my Google Drive now. Actually, I need to go to this Google Drive. Actually, this is Deva Steph, so I need to go to Deva Steph. Okay, I'm going to this Google Drive, and here I can see all the files and folder, the same things over here. So now what I have to do is, I need to create a folder and I need to paste these two things over there. So I'm just going and creating a new folder called models. Okay, so inside this model folder, I need to put these two files over there. So I'm just picking these two files and putting it over there. Yeah. So now it's uploading these two files. Actually, see, it takes only a minute. It says less than a minute to upload these two files. So actually, Google Drive will be more faster. Okay, now these two files are uploaded. Then we can go back to our Google Colab, and here just hit refresh again. So I'm just refreshing again. Then let's go inside my drive and check for the model folder. See here, you can see a model folder. So inside this model folder, we can see the two files that we have uploaded. So we need to copy the path of the model folder, not the two files. We need to copy the path of the model folder, and we need to paste it over here. It is asking your model drive directory, right? So I need to paste it here. And it is asking that we need to keep any name. Actually, now it is going to create a folder and put this model and index file into that folder. So we need to keep a name for that folder. You can keep any name you want. Since we are going to train a Neil Tyson model, so I'm just keeping Neil. You can keep any name you want. So now we need to run this code. Actually, first it is saying the copying the custom model. It is copying the custom model from drive to here, and the custom model is successfully copied. So which means now the code ran successfully. Okay, now we are coming to the final thing, that is we are going to generate a output audio that is using the model that we have already trained. Okay, the first thing it is asking for the song input. So we need to give a song input. Actually, we can give a link from online also. Like if you have a song from online, you can just give directly the link of the YouTube song. Or if you want to upload your own songs over here, you can upload it here. Actually, I want to convert my voice, and I already have created my voice over here that I used for in last video. So I want to convert this voice. We are running for 250 epochs model. So let's see how. So I want to use this one. So first I need to upload it here. Since it is just a test file that I'm going to run, so I'm just uploading it over here. But if you want to like upload a lot of files and you want to convert one by one, then you can upload in your drive, and you can copy the path of that file that you want to convert. Okay, so I want to upload this one test file. So I'm just uploading it over here. Okay, now it got uploaded. So I just need to copy the path and I need to paste it here. Okay, and it is saying that RVC directory name. Actually, we need to give exact same name that we have given here. So I need to give the same here. I'm going to explain each and every parameters and how to adjust all these things in a very detailed way. So if you don't want to watch like very detailed explanation of each parameters, then you can keep the default values and you can just hit run button and it will just create an output voice over there. Otherwise, you can skip until to the parameters tuning part. Then after the parameter tuning part, you can continue to watch to see how we can convert and do all these things. Parameter that we are going to tune is pitch change. Actually, pitch change is nothing but the names, as it name says, it is going to change the pitch of your output. Okay, here I'm going to convert Neil Tyson voice. I'm going to convert my voice into Neil Tyson voice. Actually, if you compare my voice with Neil Tyson voice will be little much deeper. Actually, compared to my voice, his voice frequency will be much deeper, which means it will be much lower than my voice. Actually, in pitch change, 0 means it is going to keep the same pitch as the voice that we are going to convert and the voice after conversion. So it will not change any frequency. But when we are giving negative value, actually it will make the voice deeper. It will make the voice into more bass. Actually, when you are giving positive value, it will increase. It will give more it will give higher frequency. Okay, in this case, we are going to convert Neil Tyson voice, and his voice is deeper than mine, but not much deeper. So I'm just going to keep -2 or -3. I can just keep anything I want. So I'm just keeping a little bass voice than my voice. Okay, then pitch change, all what it will do is actually it will not be much useful over for the tutorial that we are doing now, because RVC for now it is just for a single speaker. But if you are going to convert a model, like if you already trained a model for multi speaker and you can convert like 3 or 4% voice, then you can give pitch change all. Actually, what it will do is it will change all persons pitch into the value that we are going to give. Actually, it is just a single speaker model, so we are not going to touch this parameter now. Okay, and the next parameter is the index rate. If I'm just increasing the index rate value from 0 to 1, then it will be more sound like, the more I increase, the more it will sound like Neil Dyson, and the more I decrease, the more it will sound like my original voice. But the problem with increasing more is like I can just keep 1, which is the maximum. I can keep like index rate as full also, but the problem is it will try to sounds more like Neil Dyson, but the voice will be like a robotic voice. It will not be like a proper original voice, because it will try to maximize the conversion accuracy. So if you are keeping 0, then it will not feel like robotic voice. It feel like the normal voice that I am speaking. But the problem is it will not sound like Neil Tyson also. It will sound very well. It will sound mostly like my voice. So what we can do is we can just keep, as of now we can just keep it in 0.5, which is the average value. Actually, just remember one thing, that all this parameter that we are going to tune, it is not a fixed value. So for each and every voice that you are going to train, you need to try by trial and error method. Like you want to give your own values and see whether how it is sounding. Like if the sound just need to be adjusted, the pitch need to be adjusted, then you need to come here and you need to tune all this value. So that is why I want you to learn all these parameters, so that you can just tweak little by little and you can produce a perfect voice. Okay, the next parameter is filter radius. Actually, filter radius will take care of the pitch transition in your audio file. Okay, I'm just going to convert my voice into Neil Tyson voice. So in my voice, in my audio file that I'm going to convert, will contain lot of higher pitch and lower pitch. There will be lot of transition between higher pitch and lower pitch. So when I'm just keeping the filter radius as higher value, the more I increase the value to 4, 5 or 6, then the transition between the pitches will be more smoother, which means output audio will be smooth in transition. It looks like a normal audio speech. But the problem with this, like the more you increase the filter radius, it will lose the fine details of your model's voice, which means even though the output voice is very smooth, but it will not sound like Neil Tyson, or the pronunciation will not sounds like Neil Tyson. It is because the filter radius is high. So the more you reduce the filter radius, it will catch all the fine details, which means it will sound more like Neil Tyson. But the problem problem is the transition between the pitches will not be smooth. There will be cut in your pitch transition. So all these things will happen because of filter radius. So you need to find a value which is like optimal for your audio and your model. So I'm saying it again, there is no absolute value for anything over here. So all these things you need to try trial and error for your own audio and own model, and which works fine, that is the proper absolute value for your audio and your model. So as of now I'm just going to keep the value 3, and maybe later if you want you can just play around with this value and see how the transition changes according to the value. Okay, this parameter is for the filter radius, which means it will take care of how much fine detail that it need to capture from your audio. And this one is the pitch detection algorithm. It will take care of which algorithm to use to capture this one. So here we have two algorithms, and these two algorithms also will use GPU. Since we are using Google Colab and we have GPU, so we can use any of these algorithms and we can see how it changes. These are two different algorithms and they are equally powerful. So you can just use any of these algorithm and see how the audio conversion works. Okay, so in pitch detection algorithm, we are going to use RMVP algorithm, and this creep hop length will say how frequently you need to use this pitch detection algorithm. So here, what values we are going to set for, like if you are setting 128, which means it will say for every 128 samples, it will apply pitch detection algorithm. So the more you are increasing the value, it will take more samples and it will apply pitch detection algorithm, which means the conversion will be more faster because it is taking more values and it is going to apply pitch detection. But the problem as again is that since it is taking more values and apply pitch detection, so it will lose some fine details of your voice. So if you are reducing the value, then it will take all the minute details from your voice and it will convert into Neil Tyson voice. But the problem is it will just take smaller sample, so the conversion timing will increase. But anyway, here we are not cared about time, but here we are cared much about the output voice. So I'm just going to keep this as 64. You can just try around the values and see. I'm just reducing the hop length so that it will take this algorithm and apply for every 64 samples in my audio. Next parameter is protect parameter. As the name suggests, it will protect the qualities of the voice. Okay, I'm just going to convert my voice into Neil Tyson voice. So the more I'm increasing this value, it will protect the qualities of my voice. Like the converted voice will sound more like my voice pattern and my sound tone, and even the pronunciation of the voice will sound more like my voice than the Neil Tyson voice. So that is the another problem. The more we are increasing this value, the output will not more sounds like the voice will be maybe sounds like Neil Dyson, but the pronunciation and the sound tone will not much match with Neil Dyson. So the more we are reducing this value, the more it will try to match with the real Neil Dyson voice and with his pronunciation. But the problem with reducing it, that sometimes it will try to overmatch and it will not sound exactly the same. The output will be more like a robotic voice, or it will not sound very natural. So you need to try to find what is the proper value for your product parameter. So as of now, I care much for the output voice, not for my pronunciation or my sound tone. So I'm just reducing it to 33 0.33, and let's see how the output voice sounds. Okay, the next parameter is remix mix rate. Actually, what product is doing here is it is asking that how much value that you want to protect your voice to the target voice, and remix mix rate is asking that how much you want to mix your voice with the target voice. The more you are increasing this value, then the target voice will be more dominant, which means it will care much for the target voice and less care for your voice. And if the more you are reducing this value, then it will care more for your voice and less care for the target voice. Here we want to care much for the target voice, which means I want to fully convert my voice into Neil Tyson voice. So I'm just increasing this into 0.6 or 0.7. You can just check it proper for your audio. So all these parameters that we have discussed here, this is mainly for voice conversion. These three things are not for voice conversion, and this is just about the volume that you need to increase. This is the mainly concerned about the converted voice, which is Neil Tyson voice, and background volume is the original voice that we are using some audio, right? And this, if it contains some any instrument, then how to increase or decrease that volume. So actually, no need to change any of these values because this is nothing related to RVC model that we are doing in this series. So just ignore this one and we can go to the next parameter, that is reverb control. Okay, the last parameter is reverb control. Actually, reverb control is basically related to kind of echo. Okay, we are like going to convert our voice and how we need to take care of the echo part. Actually, reverb size is nothing but like how much big the size of the room you want. Okay, maybe I'm going to convert Neil Tyson voice and maybe I want to convert where he is speaking in auditorium, which means the auditorium size is huge, right? So I need to increase the value here. Maybe I need to keep 0.7 or 0.8. So the more I'm increasing the value, the more the hall size will be bigger, which means it will sound like he is speaking from a bigger auditorium. The more I'm just, if I just keep 0.15, which is default, if I'm just keeping 0.15, it feel like he is speaking from a smaller room. So the room will be smaller, which means it will sound like he is sitting inside a room and he is speaking. So this is up to like what is the motive of your voice conversion. If you are going to convert a voice for a public speech, then you need to increase the volume because public speech may be in auditorium or these kind of things. Okay, then we come to reverb witness. Actually, reverb witness is nothing but how much echo you want. Actually, since I'm going to convert Neil Tyson voice, I don't want much echo, so I'm just reducing the value to 0.2 or even 0.1 so that it will reduce the echo of his voice. So if I'm just increasing 0.7 or 0.8, then it will give more echo, like he will speak and the echo back will come back. Okay, then reverb brightness is it will keep the original voice than the echo voice. Actually, reverb witness is to keep how much echo voice you want, and reverb brightness is to check how much original voice you want. I want to keep more original voice than the echo voice, so I'm just increasing the dryness, which means it will keep more of his speaking and give less of the echo. And reverb damping is that how the echo you want. The echo need to be soft, or okay, maybe he is speaking in an open auditorium which is having lot of space, then the echo will be like drizzling, like we cannot understand like the echo back, we cannot understand what the echo says, it will not be much clear, right? But if he is speaking from a smaller room, then the echo bounce will be more warm and soft. And I want the converted voice need to be in a smaller room with a warm and soft voice, so I'm just increasing this value to 0.7, which means it will give some warm and soft echo. It will not give some drizzling echoes. The next thing is about like output format. What kind of output format I want, wave or mp3 file? I just want a wave file, so I'm just keep this one. Okay, so once this whole setup is done, we can just go back and we can run this code. So when we run this code, so now our voice conversion will start to take place. Let's see when it's done. Okay, so here you can see that it start to convert. Actually, it not only convert, but also it will do many more things. It will just, if your voice having some instrument, then it will try to remove the instrument and it will apply some noise cancellation, all these things, and it will convert the voice. So that's why it is showing all these details. Okay, once it shows this tick, which means that it's ran successfully and it converted, and the converted audio will be stored in this location. So if you want to check the output, what you have to do is you just need to copy this path from the slash, right? From the slash you need to copy and the whole thing and paste it over here. And after pasting, just run this one and it will load your audio and we can hear the output here.
Okay, this is a test file that we are running for 250 box model. So let's see how our model trains.
Okay, so see here we can see the converted voice that sounds like Neil Tyson voice. Anyway, still if we do some conversion over here on all this value, then it will produce a better output. Okay, if you want to download this one, you cannot just simply press here and download this one. So what you have to do is you need to go to this location and you need to download. So it says content means this area. So in this area it says AI cover gen. So you need to go AI cover gen folder, and inside that folder it says sound output. So I'm going inside sound output, and it is saying 3647 CDA. So I'm going inside 3647 CDA, and the file which is stored is testneilware.mp3. That is this one, testneilware.mp3. So click this three dot and press download. So it will download this file. So you can just download and you can store it here and you can play.
Okay, this is a test file that we are.
So by this way, you can just do this voice conversion even if you don't have RVC installed in your local system. So because I just heard that many are facing issue in installing RVC in their system, and also some they don't have proper GPU, so they are facing like the time problem, and also it is saying that CUDA not found and all these things. So this is the best way that you can convert the voice after you trained your own model. Yeah. So that's all for this video. So we will see you in the next video.